Okay, this is the worksheet that we got today. It's called Worksheet 6. It's dimensional changes, and it's practice over that. Okay, first of all, we're going to look at number 1. It says the radii of two similar cylinders are in the ratio of 3 to 5. And the larger cylinder has a surface area of 500 pi centimeters squared. Find the surface area of the smaller cylinder in terms of pi. So what we're going to do first is we're going to use this ratio right here that's given to us. It says the radii of the two similar cylinders is a ratio of 3 to 5, meaning that is the ratio of our sides, okay, or what we call our similarity ratio. So I'm going to write down SR for similarity ratio. Our similarity ratio is 3 to 5. It says the larger cylinder has a surface area of 500 pi. Well, we're talking about surface area. Okay, surface area. This is not the same as our similarity ratio, but we need our area ratio. I'm going to call it AR. And how do we find our AR, our area ratio? What we do is we take our similarity ratio and we square each number. So we say 3 squared, and we get 9. And we take 5 squared, and we get 25. So this is our area ratio. And this is how we can compare the two shapes and their surface areas. Okay, so it says the larger cylinder has a surface area of 500 pi, and we want to find the surface area of the smaller cylinder in terms of pi. So what we're going to go ahead and do is just set up a proportion. So we can say 9 to 25, which is the area ratio, is equal to, well, we can set up first, top is the smaller one, which we don't know, that's our x, over 25, which is our bigger cylinder, and we know that to be 500 pi. Now we have a proportion. To solve a proportion, we just cross multiply. So first we're going to say top left, bottom right, 9 times 500 pi, and we're going to go ahead and keep this in terms of pi. So 9 times 500, and we get 4,500, keep the pi. And then we have the second thing, x and 25. 25 times x is just 25x. How do we solve this? Well, to solve this, you just get rid of your 25. We divide by 25 on both sides. So we end up with just x on the right side. And then we say 4,500 divided by 25, and we get 180. Keep your pi. And this is in terms of pi. And that's our answer. That would be the surface area of the smaller cylinder. Number 2. The ratio of the similar rectangular prisms is 2 to 7. And the smaller prism has a volume of 64 inches cubed. To find the volume of the larger prism. Okay, we're going to do this pretty similar to what we did on number 1, except we're going to not set up a ratio. Instead, we're going to try it a different way. Okay, it works the exact same as number 1. We're just going to do it just a little bit different to see variation. Okay, first it tells us that the ratio of the two similar rectangles is 2 to 7, so we call this our similarity ratio, and we know this is 2 to 7. Okay, it tells us that the volume is 64 inches, so we're looking for volume. So in order to find the volume, we're going to change our similarity ratio into our volume ratio. To go from similarity to volume, you cube each number, so 2 cubed. 2 cubed, we get 8. And then we're going to take the other side, 7, and we're going to cube that number, so 7 cubed. And 7 cubed is 343. Okay. So we could set up another proportion, and I'm going to go ahead and write it down. We'd end up with 8 over 343, just written this as a fraction, volume ratio, is equal to, well, it tells us the smaller prism has a volume of 64, so you'd say 64 over x. We could use this one just the same as number 1, but I'm not going to. I'm going to do it slightly different. If you want to go ahead and solve this one just for fun, go for it. Instead, I'm going to use this volume ratio to come up with kind of like a scale factor for our volume. So I'm going to call it scale factor for volume. And all we do is the exact same thing. We're going to set this up. Instead of as a fraction, remember the scale factor is basically like it's upside down. So 343 over 8. Okay, what do we get for 343 over 8? 343 divided by 8. We're going to use it as a fraction. No, as a decimal instead. So we end up with 42.875. I'm actually going to use a whole decimal there. After we know this, we can multiply our smaller one, by our scale factor, and we can get our new larger volume. So we get 64 times 42.875. I'm going to go ahead and put these in parentheses just to make sure. Okay, we can go ahead and multiply these out. 64 times 42.875, and we get the answer 2,744. Okay, and this would be inches cubed. Just to make sure that we do have the correct answer, I am going to solve it the second way, just as a second way to do it. So cross multiply, left to right is 8x, and 64 times 343 gives us a huge number actually, 21,952. Solve for x, divide by 8 on both sides. X is equal to, we should get the exact same number. Just to make sure, go ahead and put it in the calculator, and you will see, yes, you do get 2,744. Either way you do it, it doesn't matter. You do get the same answer. Number 3. Actually, we're going to skip number 3. We're going to go down to number 4. It says the areas of two circles are 144 pi and 64 pi. The ratio of their circumferences is blank. Okay, so what we're going to do is go ahead and write a ratio first of what's given to us. It's telling us our areas, so we're going to write a ratio of our areas, or our area ratio, and we get 144 pi to 64 pi, and that's what's given to us. It says to turn it into a ratio of their circumferences. Well, before I do that, I want to change this into the ratio, or a similarity ratio. Okay, and to do that, to go from similarity ratio to area ratio like we did before was you squared each number. To go backwards, you're going to square root each number. So you take the square root of 144 pi. Well, the square root of 144 is 12. And we also get 64. We can take the square root of 64. And we get square root of 64 is 8. So we get 8 pi. So this is our similarity ratio. Okay, well, if you remember, you can go from similarity ratio to what we call the perimeter ratio. And these are the exact same thing. There is no difference. We also get 12 pi to 8 pi. If you think about it, what is circumference? Circumference is just the perimeter of a circle. So if we're looking for the perimeter, we're going to use the ratio of their perimeters, which is called the circumference of a circle. So the ratio of the perimeters, we already found that, was 12 pi to 8 pi. And this is going to be our answer. Next question, number 5. Two similar triangles have corresponding side lengths of 3 inches and 9 inches. If the area of the first triangle is 12 inches squared, what's the area of the second triangle? Okay, so first, it's saying that these are similar triangles, side lengths of 3 and 9. So we can go ahead and write a similarity ratio, and it would be 3 to 9. This is comparing the side lengths. Thinking about this, 3 to 9, can this reduce? It actually can reduce, and we're going to write it as each can be divided by 3, so we get 1 to 3. Okay? It says if the area of the first triangle is 12 inches squared, what's the area of the second triangle? So I don't know the base, I don't know the height, I don't even know what the triangle looks like, but we don't actually need it because we know these ratios. So what we can do is we can set up a area ratio. Okay, I'll go ahead and use a different color, area ratio. And how do we get that? Just like what we did before from the similarity ratio to the area ratio, you square them. So we say 3 squared and 9 squared. 3 squared is, except no, we're not going to use 3 squared and 9 squared. We're going to use 1 and 3, the reduced version. So 1 squared and 3 squared. 1 squared is 1. 3 squared is 9. So we get the area ratio of 1 to 9. It says the area of the first triangle is 12 inches. So we could, just like before, set up a proportion. 1 over 9 is equal to, the first is 12, which corresponds with the 1, so 12 over x. You could do this if you want to. I'm going to do it the other way. So instead, we're going to say, if the first is 12, we're going to use the scale factor. So scale factor of our area is, think of it backwards, instead of 1 to 9, it's now 9 over 1, new, divided by old. 9 over 1, which is 9. So we take our first area, multiply it by our scale factor. 12 times 9, we end up with 108. And this is our answer. We'll go ahead and use units also. This is inches squared area. Okay, next question. Number 8 says a rectangular solid has a volume of 24 cubic decimeters. Interesting, decimeters. If the length, width, and height are all changed to 1/2 their original size, what will be the new volume of the rectangular solid? Okay, so 1/2 is the scale factor. Okay, the scale factor of their sides. Okay, and we said that we could use the scale factor, think of it basically upside down, of our ratio. So this would be, since it's of the sides, this would be the similarity ratio. Given scale factor is 1/2, we're actually going to do it backwards, so it's going to be 2 to 1. This is our similarity ratio. Okay, but we're not looking for the similarity ratio, we're looking for the new volume. So we want the volume ratio. How do you go from similarity ratio to volume ratio? You cube each number, so 2 cubed and 1 cubed. 2 cubed, 2 times 2 times 2 is 8. 1 cubed, 1 times 1 times 1 is still 1. So now that we have our volume ratio, again you could set up a proportion, but instead I'm going to use a scale factor. So turning this ratio, volume ratio, into a scale factor, we get 1 to 8. And this is our scale factor of our volumes. So we take this, multiply it by our original volume, 24. So we say 24 times, I'm going to put it in parentheses, 1 over 8, our scale factor. Okay, so 24 times 1 over 8, or divide by 8, it's the same thing. You end up with 3. Okay, this is also in the same cubic decimeters as their units. Next one, number 11, says there are 250 toothpicks in a regular sized box. If a jumbo box is made of tripling the height and length only, how many toothpicks will the jumbo box hold? Okay, so if you think about it, if you ever buy a toothpick box, it would be a rectangular prism. I'm going to go ahead and try to draw this. I'm not going to make it very detailed. That line's not very good. Let's try again. A little better. Okay. Good enough. Okay, so this is our toothpick box. If you have a bunch of toothpicks in it, that's what it would look like, okay? So this is our regular sized, and we can fit 250 in here. It says if a jumbo box is made by tripling the height and length only, how many toothpicks will the jumbo box hold? So think about it. If you're putting toothpicks on the inside of a box, okay, would that be area, surface area, or would it be volume? If it was surface area, you'd be putting the toothpicks on the outside of the box. Well, you don't put the toothpicks on the outside of the box, you put them on the inside of the box and you fill the box up completely. So it's actually going to be volume. That's what we're going to be using today. So volume. Okay, so thinking about this, the box, this is a rectangular prism. How do you find the area, or volume, excuse me, of a rectangular prism? It's the same thing as any other prism. It would be big B times h, which is the area of the base times the height. Think about it. Area of the base. Well, the base is a rectangle. That's why it's called a rectangular prism. And to find the area of a base of the rectangle, you say base times height, or what I'm going to call length times width. And then you multiply that by the height. Okay? So this says we're tripling the height and length only. We're going to keep the width the exact same thing. All we're doing here is length times width times height. So if our length is being tripled, and our height is being tripled, and our width is staying the exact same, we're multiplying this by 3, multiplying this by 3. So what is 3 times 3? 3 times 3 is 9. So the entire volume of the whole shape is getting bigger by a factor of 9. We use this as like our scale factor to then find if the original box has 250 in it, multiply it by that new scale factor 9, and what do we end up getting? We get a total of 2,250 toothpicks. That's it for today's worksheet. Go ahead and work on those. Good luck on your homework, and good luck on the test coming up.